Hello there, this is Daniele from Toolchefs and welcome to this new video. Today we're going to have a look at state machines and transitions. If you don't know what a state machine is, it's a graph that lets you go from one animation to another, and this feature has been available in Atom since its first version. We're going to use the default setup that comes with Atoms, and also we're going to use the clips that are available with the default setup, so that you can follow this tutorial if you want. So most of these clips, like the main idle, main jog, main run, have already been set up so that they're loopable, and also we have other transition clips. So these clips, the transition clips, they share kind of like the endpoints of the animation. So we see frame 0 and 30. They have poses that are also available in other clips. With this I mean frame 0 of this clip has the same pose as main idle last and first frame. So if we go to frame 300, we see that the pose is the same. And the last pose here at frame 30 is the same pose that you have in the jog. So frame 24, you see, it's the same pose. So this is because, of course, we can use transition clips in a state machine, but also it's very important that the poses between these the animations are similar, so that Atoms does a good job at producing a good animation for your agents. So you'll have to help Atoms by building a state machine that uses animations that are properly set up. Also, just for in this setup, we only just have one clip that has transition frames. So by default, whenever you instruct Atoms to go from one state to another, Atoms will wait the last frame, so the end frame of the clip, before transitioning to the next state. This, as you can see for this clip, which has 300 frames, it could take quite a long time. So for instance, for this clip, if you have a scene that is running at 30 FPS, it could take up to 10 seconds. So you can tell Atoms, look, if I want to transition, actually you can use one of these other frames instead of waiting until frame 300. So here, for instance, we see that frame 50, 150, 100, they all share the same pose. So the animation that will be produced by Atoms whenever it's going to transition, even using one of these frames, is going to be good enough. But again, here it's quite important that the pose is pretty similar. It doesn't have to be completely the same, but again, it's important that is as similar as possible, at least. So once you have prepared all your clips, you can go under the State Machine tab and click on the Add button. Here you can double click and change the name if you want. So let's call it my State Machine. And if you right click in the viewport, this menu will pop up showing you the nodes that you can create. Here we're gonna just use state nodes, but you can also create locomotion states, which can use locomotion systems that are defined under the locomotion tab. I would recommend, if you don't know what a locomotion system is, to check also the video for the locomotions, simply because we can't go through everything, otherwise it will take forever. But a locomotion system is a graph that is used by Atoms based on two inputs. So you can basically, Atoms will tell to each agent, you have to go using this speed, and you're turning by this amount, and then it will basically blend clips and build the best animation possible using these two inputs. This system is very useful, especially in cases where you have like an agent avoidance and so on. But for most cases, for instance, if you want to build a stadium state machine, or even just a simple locomotion state machine, so for very basic scenarios, using states is more than enough. Again, if you are planning maybe to go from in a case and you're building like a state machine that can be reused in several scenarios, you might want to consider having also locomotion state. So you will be able again to go from, for instance, a state that plays just an idle clip or several idle clips to the locomotion state, and then you will be able to play an avoidance on your agent. Here, for each state, you can specify some parameters. Here you can change the name if you want. You can also assign a custom color if you want. Each state needs to have a unique ID. So here, if we create a new state, we see that this ID has now this state has now ID 1. You can try to change it to a state that is already, an ID that is already being used, but then Atoms will assign to this state the first available ID. This is because we use the ID to assign a state to each agent, and if you have two states with the same ID, then Atoms wouldn't know which state to apply to your agent. Okay, so that's why we need unique IDs. Here we have some parameters that are used for specific scenarios that we're not gonna go through, because we want just to build a very simple state machine and look at the transitions. With basically the maximum angle is one of them, and also the velocity. Here for each state you can start assigning clips. So here we have assigned them an idle. For each clip then you have also other parameters. So here we have the motion type, which by default is straight, and all the others are just used whenever you have turning clips, which is not something that we're gonna do and look at in this video. We have merge types that are going to be merge, exclusive, and random. The exclusive one is the one with the higher priority, then you have random and then merge. So with exclusive, whenever you have a clip that is exclusive within a state, that clip is going to be played and all the others are going to be ignored. It's particularly useful whenever you want to debug your state machines. Then you have the merge, which is gonna, whenever you have this on, is also the type with the lower priority. Whenever you have this on, all the clips that have the merge type, the merge type set to merge, are gonna be merged together. And then you can also drive the weight of each clip using a metadata that you can specify here in the tag field. Otherwise, if you keep it as random, which is the default and what is mostly used, Atoms will play one of the clips that you list here. So if you have more than one random clip, Atom will pick one of them and will play one of those. If you have also the random loop option on, as soon as one of those clips finish playing, then another clip is going to be selected and played. Here you can provide a blend frames, so this is like the number of frames that is going to be used whenever Atoms is going from one clip to another in the same state. And then here we have other options that are used mainly for clips that are again turning, which is not something that we're going to look at in this video, so we're just going to ignore them for now. Another thing that you have here, you can provide a random weight for each random clip. So with this you basically change the probability of each clip within this state. Okay, so this is all. We can create a new state. Let's call it walk. As we see here, we have already an ID, a unique ID. And then we can attach here the man walk clip. This one. Okay, so let's save this one for now. Once you have your state machine ready, you have to go on your agent type and you have to assign the state machine, because otherwise, I mean, in this case, it will use the default state machine, so it won't actually use yours. But just for this example, let's just select our state machine so we can play with it and see what's going on. So let me create an agent, just an agent. I don't want to create anything more, and let's attach a state machine module. So whenever we have a state machine module attached, what Atom is gonna do under the hood is gonna go and look at the agent type definition. It's gonna find the state machine, and then it's gonna build a graph that looks like this inside the for each agent. And then with this graph, it will be able to to play the animation that is within that state. You will be able to transition from one state to another, and so on. So now we see that we have the default ID. The state here is the same as that one, so we're playing the idle state. If I press play, let me move this thing a bit on the left. So we see that it's playing the idle state, and then if we change the state to 1, the agent is walking because it's playing the walk clip. And then also, of course, if you want, you can animate this value. You can either change the state metadata in another way, because whenever you change this value, it's actually just changing a metadata on the agent. And then you could change that manually, so you could animate it manually. So you could say I want to go from one state, from state 0 to frame 1 at this frame, and then if we press play, nothing is happening. Why nothing is happening? Because you're not telling inside the state machine that we can go from this state to another state. You do that by right-clicking on the state and then dragging and dropping a connection. So this is a transition. If you don't have a transition, you can of course have them both way like this. But if you don't have a transition, Atoms doesn't know that you actually, you know, the state machine can go from one state to another. So now if we press play, we'll see the transition after a bit. But you see, it's like it goes from the idle to the work straight away, and we don't have a nice animation. I mean, this doesn't look natural at all. So if you have transition clips, this is what you can do. So you can click on the transition, you can add clips, and here basically each transition has all the same parameters that you have on the state, and then you can select different clips. So we can say man idle to work like this. We can save. Now, as soon as I saved here, I have this little circle showing up telling me that we have a transition clip for this transition. Here we have some values. So the blend in frame value is the number of frames that we use whenever we are blending inside this transition, and out whenever we are blending out of the transition. If you don't have any transition clip, so that means that we are going from this state to this other. Only the blend in frame is used as the frames that we're going to use for blending from this state to this other state. Okay, so if now we rewind and press play, we should see that the agent is going to start playing the main idle state, main idle to work, and then it's going to play the work state machine. Yeah, sorry, the work state. Here, if you want to see what's going on, you can activate the debug option. Here is showing us all the clips that are being used by the state machine, their frame, the clip weight, also the state, and the state weight. So at a certain point, we should see the main idle to work kicking in with a frame and a clip weight, and also the weight of the state changing. And then we see that the main idle to work is playing, and then at a certain point we'll see that the main work is kicking in, and then it's just playing that clip. So this was happening. It's pretty simple, nothing too complicated really. But again, it's important that you provide this transition clip to have a nice animation. Then we can of course provide a main work to idle here, so we have also the other way around. So you can even stop the agent here if you want. So another way you can debug the state machine is using the debugger. You can open here, so state machine, and this list here will tell you the states, the clips that are being played. It would basically contain the same text or the same information that was displayed here before in the viewport. I like using the debugger because it tells me the state that is being played, the animation, and it's all in one place. Also, I can see if here there's something else in the queue. So here in the queue, it means that we have something, or either us or a module has requested that we go to the work state. Now we see that the transition is now active. So, and after a certain point, we're gonna start playing the main idle to work, and a certain point, the work state is yellow because that's that's the target state. Let's say where we want to go, and we see that after a bit, see the work state has turned green because now this is the current state. And then the state queue, we don't have the idle anymore in here. So this is very useful because especially when you want to debug your state machine, it will give you all the information that you need. Another thing that is nice to know especially when you want to debug, you can draw metadata on each agent, as you might know already. And here we have two metadata that are defining the state of the agent. So I'm gonna, so that's, I think it's current state. Let's see, what's the name? Current state, exactly. So these two metadatas are important because the state is actually the input state that we're providing to each agent during the simulation. The current state is actually the state that is being played by the agent at any frame. So if, for instance, we press play, we'll see that at the moment these two are the same because the current state is 0, so the state being played is 0, and we're not actually changing the state here. But as we see now here, which is changed to 1, state is changed to 1, but the current state is still 0 because Atom still it hasn't played the transition yet. And then after a while it should go to 1. So again, this is a nice way to see, you know, it's a way to debug your state machines if you want to see, you know, that kind of information. But that's also again displayed. It's not displayed in the debugger, but that's the same information that the debugger uses for understanding whenever it's transitioning between states. So here in this state machine, you could, you know, add more states, which is what we're gonna do. Let's add also a jog, and then we can add a clip and jog. Sorry, I have to give it the right name because it's case sensitive. And then we're gonna right click and then build the connections. And then, so that one is gonna be a man jog to walk. This one is gonna be man walk to jog, and then we have man idle to jog and man jog to idle. Great. Okay, so if we save this one and let's go back, actually we're already there. Let's make this one a bit smaller. Now what we could do is we could go, so we can go maybe at this frame. We could say, okay, I want to set a key, and then I want to for the state. So basically we're going from state 1 to state 2. So we're going to the from the walk to the jog. And now, as you see, we have some animation that is, you know, the animation that is going from idle to walk and then from walk to jog. Once again, this state machine module just drives the state metadata on each agent. You can change the state in other ways. So another thing that we could do, for instance, let's remove the animation from this. We could add a metadata. Also, one thing is that whenever you're planning to change the state and not using the state machine module, it's important that the set state on agent creation only is on. So this will set the state only on the first frame, but then we could set the state with other modules. Again, if you keep this off, the state machine will set the state at every frame. And so it could mean that you are maybe changing the state and you want to go to work with another module, but then the state machine module will actually set the state at the next frame, so your agent will actually go back to the previous state. So again, yeah, that parameter is quite important if you're planning to change the state in another way. So here we could say state, the state type is int, so we can change that value there. We can say we can do exactly the same, but just by changing the metadata. And this is super useful to do, especially if you have like your own module that is, or maybe a behavior tree that is changing the state for you. So we see that now the agents should start working as it did before. Okay, so the last thing, we can have a look at the state machine module. So here we have the start frame, you can change it. So I'm just going to explain and go through the parameters so that you can understand a bit all of them. So start frame, you can specify a start frame for your agent. You can of course override it or randomize it with you know, the attribute, the attribute randomization if you want. You can also specify frame offset, the frame rate of the agent. So if you want your agents to go in slow motion, you can set the frame rate to 0.5, like this. Let's see, whenever it starts playing, or you know, at any other value. You can of course also animate that value. The seed is just for the randomization. State random delay is just gives a delay for whenever you want to go to another state. It will actually add the randomization, so all the animation could look a bit different. We already looked at this parameter. The set frame rate on agent creation only is the same concept, so it will just set the frame rate at the first frame. If you're planning to change the frame rate metadata with any other module. Allow path search is whenever you specify a state here, and let's say, for instance, we are on state 0 and you say I want to go to state 2. If this option is off, Atoms won't be able to transition between this state from the idle state to the jog state, because there's no connection, as we said before. If you provide the allow path search, Atom will try to search for an alternative way to go to the next state that you specified, and then we'll actually go from state 0 to state 1 and we'll go to state 2. So if we can't find a path, then we'll actually use the shortest path to go to the next state. Disable foot lock will disable the foot lock. The fixed leg stretch fixes the leg stretch again, but basically what it does is it keeps the length of the leg the same, but it produces like the best results are produced whenever the legs can stretch. You can disable the foot lock on leg stretch if that's the problem, if you see that your leg is stretching too much. And you can also provide a ratio, so you can say if my leg length is higher than the start leg length multiplied by this value, then disable the foot lock. And also this one is the soft decay distance. Here you can you have other parameters for disabling the cyclips of the locomotion system. You can provide an eye field if you want with some offset. You can tell your agents if they're if you're traveling in the 3D space as opposed to on a mesh or on a plane. So if you, for instance, if you have bipeds and so on just walking, you should keep this off. But if you have like fishes or birds, then you want, or ships, you want to turn this on, yeah. And then again, here we have the debug option that we saw earlier. And this is all for this video. Thanks for watching.